In the CCSP domain 4, okay, the CCSP domain 4 is basically what we call as a cloud application security. And this domain is actually a very, very interesting domain because whatever we have discussed till now is all about the cloud platform, provider perspective, and consumer perspective and all. But this domain is about your application architecture. This domain is basically about your application and how it's basically hosted on the cloud platform. So this domain is having a so much relevancy on this, very important. So in this domain teams, to start with, the first topic is basically advocate the training and awareness of application security. Now, let's say for example, now you have an application. Okay, you have a legacy application, I will say. Okay, this application is basically hosted in the on-premises infrastructure. Okay, so when we have this application is hosted in the on-premise infrastructure, one major point we have to keep in mind is that this particular application is tested, developed, tested, and deployed with on-premises in mind. Like for example, do you remember any application hosted on your premises before 2015 or 16 with cloud tested? No, right? Whatever applications you currently have in your organization, which is a legacy applications, are tested for the on-premises. It is developed for the on-premises. It's completely developed, tested, and deployed for the on-premises. So how do you expect this application to work in the cloud? That's challenge, right? So that's one point we have to keep it. So whenever you basically go for an application architecture, one major point is that all the applications which are legacy in the business, most of them are basically designed with cloud in mind, so with on-premises. So when you try to move that application to cloud platform, when you try to migrate the application, or we can say when you try to move the application to cloud platform, it may not work as expected. You may find a lot of glitches and challenges when you're taking the application to the cloud platform. See, definitely when you say we are going to host everything in the cloud platform, regardless of DevOps or DevSecOps, whatever it is, regardless of either DevOps or DevSecOps, whatever it is, when you basically take something to cloud, it offers you a lot of benefits and efficiencies. At the same time, it also faces challenges. So one major challenge is that the compatibility issue, because this application may not work in the cloud platform like the same way it's working the on-premises. So either you may have to find some options for customizing the application architecture, or you have to add some additional controls, or it takes some time to re-architect the entire application process. So it may take some time on the process. So it's not easy for us to basically do it that way. That is one thing which we have to always keep in mind. The second thing is basically what we call as a cloud development basics. See, there is a two organizations we are having. One is basically the Cloud Security Alliance, the CSA, and there is another entity called as a Safe Code. Okay. So as per them, the when talking about the cloud development, they have defined three golden things we have to keep in mind. Three key concepts we have to keep in mind while developing an application. First is basically what we call a security by design. What is security by design? Security by design means that security is not something which we have to add after the application is deployed in production. I repeat, security is not something which we have to do deploying after the application is deployed in production. But it's not an add-on. It's something which we have to add from the earlier phases, and it should be part of the entire application SDLC process. So security is not an add-on. It is not a bolt-in or add-on. It should be basically something which should be added as a part of the entire application from the early phases itself. It's not something which we have to do from the final step. Second most important point is basically what we call a shared security responsibility. When talking about the security responsibility, most people think that it's a responsibility of CISO or CTO or application owner or security engineer. So actually understand that security is not something like a responsibility of one single person. It's a shared responsibility. To always keep in mind, security is a shared responsibility. Okay, that's a very important point. It's a shared responsibility. The third most important thing is that team security is not an add-on. Normally, what we happen is that team when you basically go for a business, the business is having some business goals and objectives, right? And security is not something which is part of that business goal. But understand that security should be a part of the business objective. Okay, like regarding that in every ask activity or task they are performing, security should be an integral aspect of that. That's a very important point. So three concepts are there: security by design, where we have to make sure that security is an integral part of the entire application architecture when while developing the application, and it's a shared responsibility, not the responsibility of one single person. And third one is it's basically it should be a business objective. That's the three key points we have to keep in mind when talking about the cloud development basics. Then the next concept we talk about is basically the common pitfalls. Okay, common pitfalls means what? So basically, when you're developing an application to the cloud or for the cloud platform, there can be a lot of challenges you may face. For example, one thing is the migration challenges. What do you mean by migration challenge, team? Like, for example, you may not be able to take it to the cloud platform because you will face a lot of application compatibility or legacy issues. Then you have a lack of preparation for moving to the cloud platform, and then you have an issue with the support from the senior management. You have a lack of the understanding of the cloud shared responsibility model, lack of a proper secure development best practices, budgeting issues, lack of technical skills for your employees. Like this, you will find a lot of challenges. That is basically what we call as a common pitfalls when you basically talk about the application architecture. So those things should be properly, you should be aware of this, because when you basically go to the examination perspective as well, you should be aware of the first 2 points, especially that three concepts I have discussed with you, plus also the common pitfalls. You should be aware of that. And team, when developing an application, so team, have you heard about the any list of vulnerabilities we have? Yeah. So basically, what happens that team, that like the same way you have a OWASP top 10 for the applications and APIs and all, there is a lot of, and that is basically there in the cloud as well. Because I am taking an application to cloud doesn't mean that I'm having something different there. So what I'm having there is the team, the OWASP top 10 application architecture I'm having. Okay, the OWASP top 10 architecture I'm having. When I take it to the cloud platform, okay, when I take it to the cloud platform, there also have the same issues when the cloud, plus they introduce a lot of additional challenges. In the sense means they have a lot of challenges like a lack of challenges in application governance, multi-tenancy, then and various other like management console, lack of proper segregation. Like this, there's a lot of challenge, lack of control, a lot of challenges are there. So I would recommend you go through the textbook where it will help you to understand the additional vulnerabilities introduced by the cloud platform. That's a very important thing. Then I'm legal and all, for sure, everything. Yeah. Then the next thing is basically what? Describe the secure software development. So basically, normally what normally what happens is that team, whenever you basically go for an application development, we follow something called as a SDLC. So why we follow as SDLC? It's a secure process. SDLC is a proper step-by-step secure process for moving the or for developing the application from requirement gathering, design, development, testing, deployment. We have a process called as SDLC. But what is the problem with SDLC? SDLC don't think about security. One major problem is the team, they never think about security. Security is never their call, because we have a customer, the customer gives us some requirements, I want to satisfy that. Except those things which are given by the customer, there is no add-ons, there is no additional things which is basically there for the which is basically there by the cloud platform. So by the SDLC. So the problem is that when you are not thinking about security much, okay, when you're not thinking about security much, you will basically face a lot of challenges. Okay, you'll basically face a lot of challenges when you basically go to the cloud platform. So how do I address that, team? How do I address that? I can address that with the help of something called as a secure SDLC. So we have a process called as a secure SDLC. So what do you mean by secure SDLC? It's a process by which security should be a integral part of the entire process. It is not an add-on. Security should be a integral part of the entire process. That's the first and the most important thing you have to keep in mind. Security should be an integral part of the SDLC. So instead of talking about only the requirements of the customer, we should clearly understand that security should be a integral part of the entire process of the development process. Like for example, let's say when talking about the step of design, we have to make sure requirement gathering, we have to make sure that the security team is properly involved there. When talking about the step called as what is that design phase, we have to make sure we have to go for threat modeling. When we basically go for a process called as development, we have to go for the proper coding practices. We have to have a DAST, SAST, IAST. So basically security and the security testing mechanisms should be an integral part of the process. That's a very, very important, we have to keep in mind. That's basically what we call a secure SDLC, and that's a most important thing we have to keep in mind. Okay, like that. And also you have to have a basic understanding of one thing, team. You should have a basic understanding of the process. Like in the process, in the sense means like you should understand how this SDLC works. Like there are multiple models for SDLC. Like we have something called as a Scrum, Kanban, Waterfall, Agile. We have different models are there. You have to go for the Agile model and the different subcategories of that. That's a very important thing. So these are the first two modules of the domain 4. So what I will tell you one thing, team. Whenever a person say that in CCSP there are some particular areas confusing or challenging for them, I have seen that this is the most important thing. This is the one which basically gives them the most challenge. The reason why this is basically become most challenge is because now this is basically this is basically coming from the what we can say, again a different perspective, not in the cloud, right? If you're a cloud person, you may not have been aware of the SDLC or the entire stuff in SDLC there, right? So that can be a challenge, but again, this domain is super important for us. You will get a lot of questions from this domain, especially from the OWASP top 10. Maybe you will also get questions regarding cloud vulnerabilities, the various challenges in cloud development, from a secure SDLC. A lot of questions you will get for sure. And again, the DevOps and DevSecOps, those kind of things are very important for you to understand for the examination. So, Harshini, that is just regarding the perspective. That's all, nothing more. Okay, it's just regarding the perspective. Fine, team. The next one is basically what, team? The next one is basically regarding applying the secure SDLC. What do you mean by applying secure SDLC? Applying secure SDLC means that now let's suppose that we are having an application which is basically there in the cloud platform. Okay. So, and I told you that we are following an approach called a secure SDLC, where we talk about security in the every phase of the SDLC. Where so there you should be aware that while designing, developing, testing, and deploying an application in the cloud platform, what are the key challenges we additionally face in the cloud? That's very important to understand the specific key challenges we are additionally facing in the cloud. That's something which we have to be aware of. Like also the various framework which can basically help us in this process, like this what is the name, ISO 27034 is also very important. NIST is having those things are very important to understand. Plus, also you have to be aware of the concept of uh, you know threat modeling. So always keep in mind in the exam also they may have a questions regarding threat modeling for sure. But understand that threat modeling is a very important process which is coming as a part of the design phase of the SDLC. It's a very important thing to understand. Even though there are multiple phases involved in it, threat modeling is basically something primarily coming as a part of the design phase of the SDLC. That's a very important point you have to keep in mind. And you have to be aware of some of the top common threat models. Like you have a what are the different types we are having, team? Stride, Dread, Pasta, Octave, a lot of things are there, right? So at least you should be aware of the Stride model and its application. You may get scenario questions on the examination regarding they may give you a scenario and they will ask you like, oh, in the Stride model, what the scenario is focusing on the Stride model, like that. Maybe you'll get a question, maybe get a question on that. Also, you have to be aware of something called as a concept of secure coding. What is secure coding? So when you're basically developing an application, what are the best practices you have to follow when writing a code on the application? What is the criticality or importance of having a configuration management versioning? Team, anybody aware of the reason why we are having a versioning for an application?
Right.
So when there is a lot of updates coming to the application, you should be able to track the changes, right? The goal of the application versioning is to make sure that you have a complete track and control of the changes happening to the application, like what all things are added, what all bugs are fixed, what all issues are addressed. Those kind of things are very important when talking about the word called as a versioning. So that are also SCM, software configuration management, is also very important, which will help us to have a track and controlling of configuration changes to that. So that's something which we have to be aware. So these things you don't have to go in detail in depth, but you should be aware of the what is a practical reason why we are having a versioning. Simple thing. Right. Then basically, the one major thing they are telling you is that there is a word called as functional and non-functional testing. Okay. We have a word called as functional and non-functional testing. So what is the difference between functional and non-functional testing, team? This is basically very, very important, and maybe it can be important for the examination. Okay. So when talking about the word called as functional testing, okay, functional means that it verifies what the software is supposed to do. Okay, it verifies what the software is supposed to do. Like for example, I will give you some requirements, and basically if this particular application is able to meet the requirements. For example, let's say I want to test something called as a login functionality. So what, give me an example of login. So basically what I'll do, so whenever there is a user who enters the proper username and password and click on login, what should happen? It should basically allow the user to log in. If there is a user who is entering an incorrect username and password, he should be he should be getting a error message, right? Like the same way, just in case if the user tried to enter the username and password, and if the username is too short when you're trying to create a username, that should show you error like that. So when there is a user who is searching for something, he should be able to get the proper search results. When a person is trying to enter a date of birth in a column, it should not basically show error. Like the same way, that is called as a functional testing. So functional testing is a scenario when we are trying to basically ensure that the application is doing what it's supposed to do. That's a functional testing. And we have we have basically functional, and the next one is non-functional testing. What is non-functional testing, team? Non-functional testing means that it is something basically talking about how the software performs in terms of performance, usability, that appearance, aesthetics, reliability, and all. Okay. For example, let's say now one thing I'll tell you. So I will tell you two scenarios, team. You tell me which one, if it is functional or non-functional. User trying to log in. Okay, user trying to log in. He enter the proper username and he enter the proper password and he is able to log in. What is that, functional or non-functional testing? User is able to log in without any issue. That is functional testing. Perfect. That is a functional testing. Now, there is 100 or 1,000 users who try to log in simultaneously, which is basically getting an error. Okay, simultaneously, huge number of concurrent users are trying to access the application to log in, like doing a load testing or stress testing. So that, tell me, what is that, a functional, non-functional testing? It's a non-functional testing with like a load testing or stress testing, right? Like that. Then then so basically, let's say for example, a user is trying to log in and he is able to log in, but it takes a lot of time for login. So what is it, functional, non-functional? Takes a lot of time to log in. Functional, non-functional? Non-functional. That is non-functional testing, right? Because the function is he is able to log in or not. Yes, he's able to log in, but taking time. So that is non-functional, right? Like that. Now like that, like for example, so there is a lot of testing we are having when talking about functional, non-functional team. Okay, like basically if you go for unit testing, integration testing, smoke testing, regression testing, UAT, user acceptance, all these are functional testing. If you basically go for something called as a non-functional, this performance testing, security testing, usability testing, reliability testing, portability testing, recovery testing, those are non-functional. So in for especially, what I always tell you is the team, you should be aware of the concept of what is a unit testing, what is a integration testing, what is a smoke testing, what is a regression testing. You should be aware of this. You don't have to memorize in depth, but you should be aware of this. Very important to understand. Okay. Also, it is very important for you to understand the concept of static testing, dynamic testing, and IAST. SAST, DAST, and IAST. Most important for you to understand. Okay, don't forget, we have a concept of a SAST, DAST, and IAST. So what is the difference? Uh, so that's a very important thing to understand, team. So how do I understand this, team? When talking about the SAST, what is a key thing? SAST is basically where you're testing the code for vulnerabilities. I repeat, SAST is a process where you're testing the code for vulnerabilities. Okay, you're not testing the application. It's a kind of a white box testing. SaaS is testing a process where you're not running it as an application, but the code is reviewed. That is basically what we call as a SAST, or static application security testing. Then we have something called as a DAST, or dynamic testing, or dynamic application security testing, where you're testing a running application for vulnerabilities. Okay, DAST, or you're testing a running application for one. That's a DAST, or dynamic application security testing. That's a very important thing. Then we have something called as a interactive application testing. So the DAS is a black box where we are not getting access to the code, right? It's a running testing. And what is the IAST, or interactive application security testing, team? So when you say IAST, or interactive application security testing, it means that, let me give an example. Now, uh, When you basically go for IAST, you are testing it like a DAST. I repeat the simple first point. When you're testing the IAST, you are testing it like like a DAST. You are testing a running application, but you will be able to trace back to the modules or the code which is causing the issue. I repeat, when you basically go for something called as IAST, you are doing the same kind of a process like what we do for what, like we do for this DAST, but the only difference is that if you basically go for this, IAST, you are able to trace back to which particular part or unit of the code has caused the issue. Okay, so that's basically so relevant and so basically helpful. Okay, that's a very, very important thing to understand. Okay, that's a SAST. So that's a IAST. So interactive application security testing. Okay. Now, the next is we have something called as SCA or software composition analysis. What is this SCA or software composition analysis team? SCA means that, or software composition analysis means that whenever you basically have an application, okay, so the application may have a lot of components we use additionally, right? For example, let's say now in the application we may use a lot of open source or third-party components, libraries, frameworks, etc. Why do we use different modules or plugins, etc., while writing a code? Anybody aware of that? So if I develop everything by ourselves, it can take a lot of time, it can take a lot of efforts, and it can make me in trouble. So what I will do is that instead of making that headache, I will basically develop an app. I will basically develop the application with a lot of third-party components like open source, or maybe like many other components, open source components, or we can say the you know like other third-party components there. So the problem is that when you basically go for that, what happens if those frameworks or libraries are having some issue? Like, let me rework on my question, the point one more time. So whenever we basically talk about using a particular framework or plugin for while developing my application, what if there is some kind of a vulnerability? What if there is some kind of a weakness in there or loophole in that particular thing we are using? It will make my application compromise, right? First problem. Second thing is that what if there is a separate licensing term for that particular uh, you know plugin or framework that can affect the licensing of my application, right? So like that, the SCA is a process and tools we use to identify and analyze the open source and third-party components within a software application, to identify vulnerabilities, to manage license compliance, to have a code quality and health, like a lot of purpose we have for the SCA. Then we need to have a proper quality assurance. Then the next one is also very important for your team, which is basically in that new curriculum when they added in 2022, which is called as abuse case testing. What do you mean by abuse case testing, team? Abuse case testing means that, let's take an example here. Now, I'm currently let's say uh, developing an application. Normally, we when we are testing the application, we test it based on test cases, right? We test the applications based on test cases. So when we are testing the application based on test cases, there is a possibility that those are basically based on the functionality requirements, right? But what if we need to basically test from an attacker perspective or a negative mindset? I will give you an example for that. So for example, let's say this is a common example I say in every batch. For example, let's say assume that you have a mobile phone. Okay, you have a mobile phone which is supposed to be water resistant or waterproof. Okay, there is a mobile phone that the manufacturer is claiming to be waterproof. So team, how do you test if the mobile phone is waterproof? Tell me. If you are the tester person, how do you test if the mobile phone is waterproof or not? You put it in water, that's all. You just put this in water for this maybe like for a few minutes, or how much they are saying, in a particular depth, and if it withstands, that passed, right? That is basically how you expect. But let's say for example, I am the user. I take the mobile phone and put it in hot coffee. I put the mobile phone in boiling hot water. I put the mobile phone in salt water. See, again, it's water only, right? That's abuse case testing. Thinking in the perspective of attack, like thinking like, so basically those are basically like not only pre-scripted scenarios. Okay, that's basically not a pre-scripted scenario. That's a whole point to understand. Okay. So in a simple words, when you talk about the word class abuse case testing, it's trying to focus on identifying the vulnerabilities and potential misuses of a system by simulating malicious or unwanted interactions to the application. Okay, like that. Perfect team. So let's get moving to the next module. So in the domain 4, we have the next module is basically what we call as use verified secure software. Again, team, this is one major thing which we have to keep in mind when you're learning this part of the examination perspective. This is one major thing which we have to keep in mind. Why? Because the entire cloud is relying on APIs. The entire cloud is relying on APIs. So APIs is one of the most important thing you have to understand. Application programming interface or APIs. Okay, so you should know, you don't have to go so much technical on this because you're a CCSP, you're a cloud security professional, you're not the programmer there. So there's no point of going through this in depth on to the, dig into the depth. There's no need of doing that. But instead of doing that, what we have to do is that when you basically go for something called as a API, okay, when you basically do something called as an API, what we have to do is that you have to actually understand what is an API, how the API works in a cloud side. Basically, whatever request you are making, the API is the one who basically take it to the orchestration layer. You should know that the APIs are there. Then you should know that the API is basically having a host base of two types, that is the REST API and SOAP API. And you should understand that which what the differences are very important, team. Again, you should know that Rust is a more simplified version. Rust do not have an inbuilt security mechanism, and how the Rust is working. Also, you should know the SOAP API. What is it? SOAP have inbuilt security? Like the same way, just make sure you go through that Rust and SOAP difference, because in the examination perspective, it is very important for you to learn the difference between Rust and SOAP. Just make sure you learn the difference between Rust and SOAP API. Very, very important for you to understand. Okay.
Okay, REST
Next,
and SOAP.
SOAP,
Okay,
Simple
there two
Object
types
Access
of
Protocol,
API.
Simple Object Access Protocol, and REST stands for Representational State Transfer.
Okay, okay.
When you basically go for the APIs, there is a lot of mechanisms for securing the APIs, including like like we have a tool, the OWASP. We have a OWASP top 10 for the APIs. We should see whenever you go for an API. Let me tell you some points on this. Let's say, for example, when you go for an API, whenever the default API is given by the provider, it's their responsibility for securing it. But at the same time, when you use a third-party APIs for your application on the cloud and all, the biggest challenge we are having is that this APIs, we don't have a visibility over it, right? I'll give you an example there. Let's suppose that now we have this is my application here. Okay, this is my website or web application here. Okay, so in this website or application we are having, we want to have a Google map. Okay, we want to get a Google Maps here. So I can't get the entire Google map code here, right? So what I will do, from the from Google, what I will do, I will get a simple small piece of code called as Google Map API. I'll put the code here, and it will bring the entire functionality of Google Map to my application, like you have it in Uber and all, right? Like the same way. Now, if this API is not secure, if the API is compromised, if the API is not secure, what will happen? It can lead to application compromise. So we should make sure that there should be a secure process for onboarding the APIs. Like the same way in your company, you have a process for onboarding your application. You are having a proper testing process for onboarding your application. For APIs also, you should have a proper secure onboarding process. It's a very, very important thing to have a secure onboarding process for your application. Very, very important for you to understand. The second thing is that when you basically have an API, the API should be continuously evaluated and approved before it can be used in production, and you should test it regularly like that. Okay, these are the key things which we have to keep in mind. And always keep in mind, if the APIs are insecure, it can lead to application insecurity as well, for sure. So that is basically, we can use different tools for that. We have a mechanisms, like we can do the API, we can go for something called as a OWASP top 10 for APIs and all. You don't have to go so much technical on this to learn all those things, because why? Because see, in CCS we should know that there should be a process for securing the APIs. That's all. Means you don't have to basically learn about the entire process for securing the APIs one by one. Means again, the testing process we don't have to know like that. Okay.
Okay.
Now, the next one is basically what we call a supply chain management. What is supply chain management, team? Supply chain management, I'll give an example. Now, supply chain means what? In a simple word, supply chain means that. So let's say, for example, we have an application. Let's say this is we have an organization here. So we want to develop an application. So I outsource my requirements to another company. Okay. I want to develop an application. I outsource my requirement to another company. This company is outsourcing some other part of it to this another company. And this company is giving it to another company. So if something happens here, some vulnerability happens here, it will travel here. go to here. At the end, it will affect my organization, right? That's a supply chain issue. Okay, that's a very common thing which can. Like the same way, when you're basically developing an application, for example, let's say now we have an application here, and let's say, for example, I'm using an API here. So what will happen? So if this API is given by another company, okay, we have my customers here. This is my company, and this API is given by another is basically given by another company, and this company is using some other companies there. So if there is any issue happens here, it will entirely compromise my application and it will affect me only, right? So making sure when you're onboarding a vendor, you should basically evaluate the vendor based on some criteria. That's basically what we call a supply chain management. The same topic is coming in the domain 4 and domain 6 as well. Okay, then basically we have to understand that whenever we are basically onboarding an application, one major thing is the third party software management, because the licensing and all the things regarding onboarding an application, that's a third party software management, is a very important thing we have to understand. Then again, when using application, use of open source components also is a very important thing. This is basically just an overview you have to understand from this particular module. The most important thing you have to keep understand here is the API part. You should be aware that the API types and all. Okay, I'm not going in depth on that because again it will take a lot of time for us. So I'm just giving an overview. That's all. Okay, the next is basically comprehending the specific of cloud application architecture. So whenever you're basically using an application in the cloud platform, it is a very important challenge that the application security components. One major thing is basically the WAF. So team, I hope all of you know the difference between WAF and normal firewall. In a quick overview, can anyone define the difference between WAF and normal firewall, team? A quick overview from the difference between WAF and normal firewall. Okay, so when you basically go for a firewall, team, when talking about the normal firewall, which is talking about the layer 3 or layer 4 firewalls, both functionalities can be available, either WAF or normal firewall. Both can be available in hardware and software. But when talking about the firewall, normal firewalls are working in the layer 3 or layer 4 firewalls, which is basically where it filters with the packet based on port protocol, port number, source IP, destination IP, etc. And they don't basically work inside based on the cookies or, or the packets and etc. At the same time, if you go for web application firewall, that is something which can go a slightly bit advanced, which can filter traffic based on the layer 7 on the application layer. That means it can review the packets and filter based on the packets, like to prevent against attacks like SQL injection, cross-site scripting, and multiple other attacks. The WAF is something which can basically protect you from some series of layer 7 attacks. So basically, let's say for example, now you have a packet coming from a location. If you go for a normal firewall, it can only protect based on the protocol, port number, source IP, destination IP, etc. But say if you go for web application firewall, it can basically protect you from multiple sophisticated attack which can possibly happen inside using the application packets inside. Okay, that's a layer 7 thing, application layer thing. Then we have something called as a DAM or database activity monitor, which can basically monitor all the queries and requests coming to your particular databases. It's a functionality now which is there for almost every enterprise databases as a part of it. Then what is XML firewall, team? XML firewall is a very, very simple thing actually. So when you're talking about the word called as XML firewall, it means that it is a kind of a firewall, okay, that is specialized on focusing securing applications that uses the XML for communication. See, now let's say for example, when you talk about multiple APIs or multiple things, many of the things use API, means this XML, which stands for extended markup language. Do you know why many communication happen via XML? I'll give you a simple example. Now let's say you have an application here which is communicating to another server or another application server. Okay, now this is basically by your company, this is basically by another company. Now do I have any guarantee that these two applications these do I have any guarantee that these two applications are or written on the same language? Can I always ensure that these two applications are on the same language? No, right? So in that case, what happens? As I can't ensure that this is the same, I can use XML for communication, because XML is a language which is platform and language independent. XML is a language which is platform and language independent. As they are platform and language independent, okay, they are something which is basically, they are something which basically can also be vulnerable for multiple attacks. So XML firewalls are something which is basically focused on securing applications that are using XML for communication, okay, like that. And always, and like the same way we have a web application firewall, XML firewall also operates in the application layer. XML firewall also operates in the application layer. Okay, just have to understand, that's all. Then then we have the API gateway. So team, this is a very important point. Okay, API gateway is always a critical topic when you basically go for CCSP, because I have seen this multiple times in many discussions and all. API gateway is a very important thing. So when talking about the API gateway, let's say for example you have an application. Okay, but whenever there is a request coming to the application, we have multiple concerns. Okay, whenever there is a request coming to the application, we have multiple concerns. What is the concern number one? Okay, is the request coming to my application is properly authenticated? Is the request coming to my application is properly authenticated? Is the request coming to my application is properly authorized? Do they have permission to make the request? How many number of requests? How many number of requests is coming to my application? To which server I have to forward the request? Like this, for all these questions coming up, to solve it easily, you can put, so this is if this is your application, you can put an API gateway in front of it. So basically by putting an API gateway, what happens, team, it acts like a reverse proxy, I can say. That means when a request is coming to the API gateway, first of all it verifies the API request coming, whether it's they are authorized to send the request. Then also it basically uh, help you to make sure that limit the number of requests coming to the application simultaneously. It always try to limit or help us to limit the number of requests coming to the application simultaneously. Also, it will help us to basically have a proper authorization and authentication for the request, and forwarding the request to the particular exact correct backend services, like that. All these things can be done by API gateway. Whenever I talk about the modern application architecture, the API gateway is a core component of it. Okay, that is testimonial the exam, a very important team. Also, you have to keep in mind when you basically go for multiple interviews as well. You don't have to know it technically, but in a management perspective, you should aware that this is basically a very important topic to understand. Okay, the next one is that team we have something called as a cryptography, obviously talking about the encryption and all. Then we have a sandboxing. So sandboxing means what, team? This is a common term you will hear actually when talking about the application and all. Now let's say for example, what is the reason why I don't test an application or a particular new piece of application or a new version of application in my production? It not safe. It may contain malware. It can make the things unsafe. It can basically increase security threats. It can open new vulnerabilities, right? To avoid that, what we do is that we have a process called as a sandboxing. So sandboxing means what? We are creating a isolated virtual environment. Don't forget, when it is a sandbox, we are creating a isolated virtual environment to run any kind of untrusted program or code or file. So what is the benefit there? When you basically run that untrusted program or code or file in a completely isolated environment, whatever harm happens, it will be always limited inside that particular sandbox you create. Like especially when you go to cloud, it's more easy. Like you can create virtual machines or you can create PaaS platforms, which is completely separate. And whatever compromise happen, whatever issue happen, stays within that system or network. It won't basically go to the production like that. Okay, the next is basically we have something called as a concept of application virtualization. Okay, what is this application virtualization? So that's a name you have not much heard first, but again, so application virtualization is a scenario where I want to basically to have an application which is running, okay, and which we encapsulate the application from the underlying operating system. So don't forget, the application virtualization is a scenario where I want to make sure that I'm able to encapsulate my application separately from my underlying operating system where it's running. Okay, that's what basically we call it as a application virtualization. Now tell me, team, which one is basically nowadays, what is the best place where I can run an application completely encapsulated without affecting the underlying operating system? Containerization. Containers can basically help us to run our applications with completely pre-packaged without depending on the underlying operating or without depending or without getting connected to the underlying operating system. Is it clear, team? That's a very important point. So when you say application virtualization, it's a software technology that help us to encapsulate our application from the underlying operating system where it's running. And basically, you don't have to worry about the application dependency. It's already pre-packed. That's a containers. Okay. Then we have something called as microservices, basically like serverless is an example, where we don't have a server to work with. We don't have to worry about that. It's basically the provider's responsibility for providing servers and platform. We just has to run the code based on a trigger. That's called as a serverless, right? Like that. So, team, like the same way we have all these things. Okay, this is basically very important for us, team. When talking about identity access management, it is very important for to learn about as I told in the domain one. In here also, you have to learn about authentication, authorization, accountability. Also, we have to learn about the concept of two most important things. One is federation, and one is SSO. There are so two things to understand. One is basically what we call as federation. One is what we call as SSO. When you basically go for federation, what do you mean by the team? Federation is basically the process of, you know, using one identity from one domain to authenticate and authorize in another domain. Like for example, let's say using your Facebook ID, you are able to log into some websites, right? You're using your Gmail ID, you are able to log into multiple other applications, right? Like that's basically what we call as a federation. Okay, so federation is a process of doing that particular perspective. But if you go for SSO, what do you mean by the team? It's a single sign-on where using one single set of credentials, user can avoid logging in multiple times. So for example, let's say for example, we have a corporate application number one here. We have a corporate application number two here. We have a corporate application number three here. And so basically what happens, team? So using one set of credentials, I'm able to log into all these things. Okay. And without re-entering that, that's basically what we call as a SSO. And especially when you go to cloud and all, this SSO federation is a very, very common concept you have to understand. And in the SSO, there are three components. In the SSO and federation, we have three components. One is identity provider, one is service provider, one is a principal. Who is identity provider? Like for example, you log in with your Facebook credentials, or you log in with a Gmail credential to website. So you are the principal. Facebook, where you have the identity, is called as identity provider. With the website you're trying to log in is called as a service provider. So you should know about the concept of IDP, identity provider, service provider, and principle. Also understand the difference between federation and SSO. Then understand that whenever you talk about identity and access management in the cloud, it's very important for you to have something called as a multi-factor authentication, because MFA is a very important concept, right? At the end of the day, if you want to have proper security, one major concept which can help you for achieving that is basically the multi-factor authentication. So that's about the domain 14, which is called as application security. Even though you may feel this domain is basically, this domain is basically something which is completely a bit slightly different from what you have learned before, but I would recommend that you have to give more critical importance to this domain, because there may be many questions coming from this domain which may confuse you. So please make sure you review this domain thoroughly. Okay, that's it.